On the morning of April 19th, 1943, Hauptmann Klaus Becker stood in the testing yard at Kummersdorf, 25 kilometers south of Berlin, watching something that should not exist. The vehicle before him was American. That much was obvious from the white star still faintly visible beneath hastily applied German markings. It had been captured 3 weeks earlier in Tunisia, dragged from a smoking battlefield near El Gueta where American tank destroyer battalions had savaged the 10th Panzer Division. 21 German panzers destroyed, 38 damaged. The Americans had lost vehicles too, but far fewer than they should have. This one, designated Beutepanzer M10 in German records, had been shipped to the Kummersdorf proving grounds for evaluation. Becker commanded the captured vehicle testing section of the Waffenprüfamt, the weapons testing office. His job was to understand enemy equipment, to find its weaknesses, and to determine whether Germany's own designs remained superior. He had evaluated dozens of Allied tanks, British Matildas captured at Dunkirk, French Char B1s from the 1940 campaign, Soviet 34s pulled from burned-out hulks on the Eastern Front. He knew what to expect from enemy armor: heavy steel, slow engines, conventional designs that conformed to established doctrine. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The M10 conformed to nothing. Its turret was open to the sky, no roof, no overhead protection. The crew compartment exposed to shrapnel, grenades, aircraft fire, anything falling from above. German assault guns like the Stug 3 had enclosed fighting compartments. Even the Marder series of improvised tank destroyers rushed into service to counter Soviet armor, provided overhead cover for their crews. This American vehicle offered none. Becker walked a slow circle around it. The hull was familiar, clearly based on the M4 Sherman chassis his team had already evaluated. But the superstructure was different. The turret sat low on the hull, pentagonal in shape, made from welded armor plate rather than cast steel. 2 large counterweights protruded from the rear of the turret, giving the vehicle a distinctive hunched appearance. The main gun was a 76mm weapon, the American 3-inch anti-tank gun, respectable penetrating power. Not extraordinary, but adequate against most German armor except the newest heavy tanks. What troubled Becker was not the gun, it was everything else. Obergefreiter Ernst Richter, one of Becker's test drivers, approached from the motor pool. Richter had driven panzers since 1941. He had crewed Panzer IIIs in France, Panzer IVs in Russia. He understood armoured vehicles the way a craftsman understands his tools. Becker valued that experience. "The engine is ready, Herr Hauptmann," Richter reported. "We have fueled it and completed the pre-inspection." The Americans use a twin diesel configuration, 2 Detroit engines coupled to a single transmission. Strange design, but it appears functional. Becker nodded. "Mount up. We will run it through the standard mobility tests. I want maximum speed measurements, acceleration rates, turning radius at various speeds, and fuel consumption data. The staff wants a complete evaluation by week's end." Richter climbed onto the hull and dropped through the open turret into the commander's position. Another technician, a young mechanic named Schmidt, took the driver's seat. The engine rumbled to life, the distinctive sound of American diesel engines echoing across the proving ground. Different from the gasoline engines that powered most German armor, rougher, more industrial. Becker stepped back as the M10 lurched forward. It moved smoothly, the suspension absorbing the uneven ground of the test course. Schmidt guided it through a series of turns, then accelerated down a measured straight section of the track. Becker watched through binoculars, timing the run with a stopwatch. The vehicle covered the distance faster than he had expected. Much faster. When the M10 returned to the starting position, Becker consulted his notes. "Again," he ordered. "Full throttle this time. I want to confirm these numbers." Richter's voice came through the vehicle's open turret. "Understood, Herr Hauptmann. Full speed." The M10 surged forward, diesel engines straining. It covered the measured kilometre in just over 2 minutes. Becker did the mathematics quickly in his head. The numbers could not be correct. He had Richter run the course 3 more times. Each run produced similar results. Finally, Becker called for a halt. Richter dismounted, his face puzzled. The speedometer indicates 30 miles per hour, Herr Hauptmann, perhaps higher on level ground with more distance to accelerate. I have never driven a tracked vehicle this fast. Not with this much weight. Becker stared at the M10. 30 miles per hour. 48 kilometers per hour. For a fully tracked vehicle mounting a 76mm gun and carrying nearly 30 tons of steel and ammunition, the number defied conventional understanding of armoured vehicle design. Germany's Stug 3 assault gun, the most produced German armoured vehicle of the war, could manage perhaps 25 miles per hour on level roads. Maybe. The Panzer IV, Germany's primary medium tank, achieved a similar speed. The massive Tiger heavy tank, the pride of the Panzer forces, topped out at 23 miles per hour when everything worked properly. But this American tank destroyer, this improvised vehicle built on a medium tank chassis, could outrun them all. Becker understood immediately that this was not about raw engineering superiority. The Americans had not discovered some secret metallurgical process or revolutionary engine design. They had simply prioritized differently. The key lay in what the M10 lacked, not what it possessed. No turret roof meant less weight. The armour was thinner than German fighting vehicles. The hull sides measured 19 millimeters, adequate to stop rifle fire and shell fragments, inadequate against dedicated anti-tank weapons. The frontal armour was thicker, perhaps 50 millimeters, effective thickness, but still lighter than German standards. The Americans had made a calculated trade. Protection for speed, safety for mobility. It was a philosophy that made German armour officers deeply uncomfortable. That afternoon, Becker convened a meeting with the Kummersdorf technical staff. A dozen officers and engineers crowded into the briefing room, examining the preliminary test data. Major Wilhelm Kessler, the senior ordnance evaluation officer, studied Becker's report with growing skepticism. 30 miles per hour? Kessler said. You are certain of these measurements? I observed 5 separate test runs, Herr Major. The results were consistent. The vehicle can sustain that speed across level terrain. Acceleration is rapid. Fuel consumption is higher than our vehicles, but the Americans appear unconcerned with efficiency. Kessler set down the report. What about the open turret? What possible tactical justification exists for exposing a crew to overhead fire? Becker had spent the afternoon considering that question. He had climbed inside the M10, examined its layout, studied its design philosophy. The answer, when it came, revealed something profound about how the Americans understood armoured warfare. Observation, Herr Major. The open turret provides exceptional visibility for the commander. He can see in all directions without relying on vision ports or periscopes. He can communicate directly with accompanying infantry without opening hatches. In close terrain, hedgerows, villages, forests, this visibility advantage could be decisive. At the cost of vulnerability to grenades, artillery airburst, and strafing aircraft, Kessler countered. The trade seems foolish. Perhaps, Becker conceded. But consider their doctrine. The Americans do not employ tank destroyers as we employ assault guns. Our Stug battalions are defensive formations. We position them in ambush, exploit their low silhouette, wait for enemy armour to advance into killing zones. The Americans appear to use their tank destroyers offensively. They move rapidly to threatened sectors, engage enemy armour in fluid battles, then withdraw before enemy forces can concentrate. For that mission, speed matters more than protection. Observation matters more than overhead armour. The room fell silent. The implications were troubling. Germany's approach to tank destroyer design had evolved from years of combat experience. The Stug 3 had proven devastatingly effective on the Eastern Front. Low profile, heavy armour, powerful gun, operated by artillery crews trained in precision gunnery from static positions. The vehicle had been credited with thousands of Soviet tank kills. It was, by every measure Germany understood, the optimal tank destroyer. But it was not fast. The Stug 3's top speed of 25 miles per hour was adequate for moving between prepared positions. It was inadequate for pursuing retreating enemies or racing to counter breakthroughs. German doctrine did not require such speed because German defensive tactics emphasized static firepower over mobile response. The Americans had designed something different, not better in every dimension, but optimized for a different kind of warfare. Kessler leaned back in his chair. Continue the evaluation. I want detailed reports on reliability, maintenance requirements, ammunition stowage, gun performance. Berlin will want to know whether we should modify our own designs based on what the Americans have built. Over the following week, Becker's team subjected the captured M10 to exhaustive testing. They fired its main gun at captured Soviet armor, measuring penetration at various ranges. They drove it for hundreds of kilometers, monitoring mechanical wear and breakdown rates. They timed how quickly crews could load and fire. They measured fuel consumption under different operating conditions. Every test revealed the same pattern. The M10 was adequate but not exceptional in any single dimension. Its gun could penetrate most German armor at reasonable ranges, but struggled against heavy tanks like the Tiger. Its armor could resist small arms and shell fragments, but offered minimal protection against dedicated anti-tank weapons. Its mechanical reliability was good, better than many German vehicles, but not dramatically superior. What made the M10 exceptional was how all these adequate characteristics combined with extraordinary mobility. The vehicle was fast enough to choose when and where to fight, fast enough to evade counterattacks, fast enough to exploit breakthroughs and pursue defeated enemies. In the fluid, mobile battles that characterized the North African campaign and would soon characterize the fighting in France, that speed mattered more than thick armor or massive guns. Obergefreiter Richter, who had driven the vehicle daily during testing, summed up his impressions in his official report. The M10 handles like a truck, not like a panzer. It is designed for speed on roads and firm ground. The suspension is simple, the controls are straightforward, the engine is reliable. An inexperienced driver could operate it effectively after minimal training. By contrast, our Panthers require experienced drivers who understand the fragile transmission and temperamental final drives. The Americans have built a tank destroyer that ordinary soldiers can drive. We have built tank destroyers that require specialists. The observation cut to the heart of a larger problem Germany faced by 1943. Every year of war consumed experienced crews. The veterans who had invaded Poland and France were dead, crippled, or scattered across a 1,000-mile eastern front. Replacement crews received shortened training because the fighting never stopped. Germany needed weapons that experts could employ to devastating effect, yes, but it also needed weapons that adequately trained soldiers could operate without constant breakdowns. The M10 represented a design philosophy that accepted good enough performance across multiple dimensions rather than excellence in a few. The trade-offs frustrated German engineers who prized technical sophistication, but the approach had undeniable advantages for a nation with vast industrial capacity and a massive manpower pool. On April 30th, Becker submitted his final report to the Waffenprüfamt. The document was 17 pages of technical specifications, test results, and tactical analysis. Its conclusion was measured but clear. The American M10 tank destroyer represents a coherent design optimized for offensive mobile warfare. Its speed, reliability, and ease of operation compensate for deficiencies in armor protection and gun performance. In defensive operations where our assault guns excel, the M10 would be vulnerable. In offensive operations where mobility is paramount, the M10 would be superior to our current designs. Recommendation: Germany should develop high-speed tank destroyer variants capable of similar mobility while maintaining superior firepower and protection. The report travelled up through military bureaucracy, eventually reaching the desk of Generaloberst Heinz Guderian, Inspector General of Armoured Troops. Guderian read it with interest. He had pioneered German armoured doctrine, had commanded panzer divisions during the French campaign, understood mobile warfare better than almost any officer in the Wehrmacht. He also understood that by mid-1943, Germany's strategic situation left little room for experimental vehicle development. The factories were struggling to produce enough Panthers and Tigers to replace combat losses. Resources did not exist to design and build entirely new classes of tank destroyers. The Americans, meanwhile, were producing M10s by the thousands. General Motors' Fisher Tank Arsenal in Grand Blanc, Michigan, had manufactured nearly 5,000 of them by the end of 1943. Ford built another 1,000 of a variant model. The vehicles equipped dozens of American tank destroyer battalions that were spreading across North Africa, preparing for the invasion of Italy, training for the eventual assault on Fortress Europe. Germany captured more M10s as the war progressed. They appeared on battlefields in Sicily, Italy, and later in France. German crews occasionally pressed them into service, painting Balkenkreuz crosses over American stars, using captured ammunition until supplies ran out. These Beutepanzer served with ad hoc formations, replacement units, and training commands. But Germany never adopted the M10's design philosophy. The vehicle existed as a curiosity, a trophy, a reminder that other nations approached armored warfare from fundamentally different perspectives. What the Americans understood, and what German doctrine struggled to accept, was that speed itself was a form of armor. A moving target was harder to hit than a static one. A vehicle that could disengage from unfavorable combat was more survivable than one forced to fight where it stood. An army that could concentrate force rapidly at decisive points could win battles even with inferior equipment. The M10 embodied this philosophy. Its open turret, its light armor, its powerful engines, every design choice reflected the belief that mobility and rapid response mattered more than invulnerability. When American tank destroyer battalions deployed to Europe in 1944, they brought with them this doctrine of aggressive, mobile, anti-tank warfare. They did not wait in ambush for German panzers to appear. They hunted them. They raced forward to threatened sectors, engaged enemy armor at range with their 3-inch guns, then withdrew before German forces could organize counterattacks. When heavier German tanks appeared, Tigers and Panthers immune to frontal hits from the M10's gun, American crews adapted. They used their speed to flank. They coordinated with other units to create crossfires. They called in artillery and air support, while maneuvering to positions where even Panther side armor became vulnerable. The Germans, watching these tactics unfold, recognized a fundamental difference in military culture. American forces accepted that individual vehicles might be destroyed. What mattered was accomplishing the mission, and missions were accomplished through coordination, through overwhelming firepower brought to bear from multiple directions, through refusing to fight on terms that favored the enemy. German doctrine emphasized vehicle quality, because Germany could not replace losses as quickly as its enemies. Each Panther represented months of skilled labor, specialized steel, precision machining. Losing one was a strategic defeat, not just a tactical setback. So German tanks were built to survive, to win individual duels through superior armor and firepower, to minimize losses even when this meant accepting reduced mobility and increased mechanical complexity. The Americans built disposable armor, not cheaply made, not shoddily constructed, but designed with the understanding that losses were acceptable if missions succeeded. The M10 cost less than a Sherman tank. It required fewer specialized components. It could be manufactured quickly and shipped in quantity. When one was destroyed, 3 more arrived from the factories in Michigan. This industrial approach to warfare horrified German officers trained in a tradition that valued craftsmanship and technical excellence. But it worked. By the spring of 1944, as Allied forces prepared for the invasion of Normandy, American tank destroyer battalions had refined their tactics to devastating effectiveness. The M10, despite its vulnerabilities, despite its open turret and light armor, had become one of the most successful Allied anti-tank weapons of the war. Not because it was the best tank destroyer ever built. It was not. Not because American crews were better trained than German crews. They often were not. The M10 succeeded because it matched American doctrine, American industrial capacity, and American strategic objectives. It was fast enough to matter, reliable enough to sustain operations, and simple enough that citizen soldiers could employ it effectively after months rather than years of training. Hauptmann Becker never learned how his report influenced German vehicle development. He continued evaluating captured Allied equipment at Kummersdorf throughout 1944, watching as ever more sophisticated American weapons arrived for testing. Sherman tanks with 76mm guns, M18 Hellcat tank destroyers that could reach 55 miles per hour, M26 Pershing heavy tanks that finally matched German armor in protection and firepower. Each new vehicle refined the American approach: more speed, more reliability, more industrial efficiency. By the time Soviet forces captured Kummersdorf in April 1945, the proving grounds held dozens of Allied vehicles in various states of disassembly. Test reports filled filing cabinets. Technical drawings covered office walls, all of it documenting how America and Britain and the Soviet Union approached armored warfare differently than Germany. The captured M10 that Becker had evaluated in April 1943 sat abandoned in a corner of the motor pool, its engine removed for analysis, its turret rusting in the spring rain. The vehicle had travelled from a factory in Michigan to a battlefield in Tunisia to a testing ground in Germany. It had been driven hundreds of kilometres, fired dozens of test rounds, subjected to every evaluation protocol German engineers could devise. In the end, it proved what Becker had suspected from the beginning. Wars are not won by individual weapons, no matter how technically advanced. Wars are won by nations that match their weapons to their doctrine to their resources, and their resources to their strategic objectives. The M10 was never going to be remembered as the best tank destroyer of the Second World War. That distinction belonged to vehicles with heavier armor and more powerful guns. But it would be remembered as one of the most numerous, one of the most reliable, and one of the most effective at accomplishing its intended mission. And that mission, as Hauptmann Becker finally understood, was not to win individual battles against superior German panzers. The mission was to help win a war. The story of how the M10 came to embody American armored doctrine began long before German engineers examined captured examples at Kummersdorf. It began in the desperate months after Pearl Harbor, when American military planners confronted a brutal reality. The United States Army had virtually no anti-tank capability. The 37mm anti-tank gun that equipped American forces was obsolete before the war started. It could not penetrate German or Soviet medium tank armor at combat ranges. American tanks were designed primarily for infantry support, not for destroying enemy armor. That mission belonged to a new organization that existed more in theory than in practice, the Tank Destroyer Force. General Leslie McNair, commanding Army ground forces, championed the tank destroyer concept with almost religious fervor. McNair believed that specialized anti-tank units, held in reserve and rushed forward to meet enemy armored breakthroughs, represented the most efficient use of limited resources. Rather than building thousands of heavily armored tanks to counter German panzers directly, America would build thousands of fast, lethal tank destroyers that could ambush and destroy enemy armor before withdrawing to fight again. The doctrine was called Seek, Strike, and Destroy. Tank destroyers would not hold ground. They would hunt. They would appear where least expected, deliver devastating fire, then vanish before enemy forces could respond. For this mission, speed mattered more than armor, firepower mattered more than protection, and the vehicle that best embodied this philosophy was the M10. Development of the M10 began in early 1942. Army Ordnance evaluated multiple designs mounting various anti-tank guns on different chassis. The winner was designated 35E1, a 3-inch gun mounted on a modified M4 Sherman chassis with an open-topped turret and sloped armor. In June 1942, the design was standardized as the 3-inch gun motor carriage M10. Production began at General Motors' Fisher Tank Arsenal in September. By December, the first vehicles were rolling off assembly lines at a rate that would have seemed impossible to German planners. Ford Motor Company joined production in October, building a variant model powered by a different engine. By the end of 1943, more than 6,000 M10s existed. No other nation on Earth could have produced so many specialized armored vehicles in such a short time. The scale reflected America's unique industrial capacity and its approach to war production. Henry Kaiser was building Liberty ships in days. Ford was mass-producing B-24 bombers on assembly lines. General Motors applied the same principles to tank destroyers: standardized components, interchangeable parts, assembly line techniques adapted from civilian automobile production. The M10's chassis came from Sherman tank production. Its transmission used proven commercial automotive technology. The 3-inch gun was a naval weapon adapted for ground use. Every component had been designed for mass production by workers with minimal specialized training. The contrast with German vehicle production could not have been more stark. German assault guns and tank destroyers were precision-engineered machines requiring skilled craftsmen to manufacture. Panthers needed specialized machine tools to produce their complex transmissions. Tigers required armor plates so thick that only a few factories could work it. German vehicles were individually superior. American vehicles were collectively unstoppable. By the time Hauptmann Becker evaluated his captured M10 in April 1943, American tank destroyer battalions were already proving the doctrine in combat. The Battle of El Guetar on March 23, 1943, marked the combat debut of both the M10 and the tank destroyer concept. The German 10th Panzer Division, commanded by General Major Fritz von Breuch, attacked American positions near the Tunisian village of El Guetar. Von Breuch had every reason for confidence. His division included veteran crews who had fought from Poland to France to Russia. They were attacking green American units whose only combat experience had been the disastrous encounter at Kasserine Pass a month earlier. German intelligence suggested the Americans were poorly trained, easily panicked, and inadequately equipped. The attack should have been a repetition of Kasserine. Instead, it became a slaughter. The 899th Tank Destroyer Battalion, equipped with new M10s, held positions along the ridges overlooking the battlefield. They waited in hull-down positions, only their turrets visible above the crest, watching as German panzers advanced across open ground. Lieutenant Colonel Herschel Baker commanded the battalion. He was a West Point graduate who had spent years studying anti-tank warfare in theory. Now he would test that theory against the finest armoured force Germany possessed. Baker positioned his M10s carefully. Each vehicle occupied a position that maximised its field of fire while minimising its exposure. The crews had dug their vehicles into the rocky hillside, piling stones and dirt around the hulls for additional protection. Only the turrets and guns were visible from the valley below. When the Panthers and Panzer IVs came into range, American 3-inch guns opened fire with devastating effect. Staff Sergeant Robert Lupe commanded one of the lead M10s. He had been a machinist in civilian life, working in a Detroit factory before the war. Now he sat in the commander's position of a 30-ton vehicle, watching enemy armor advance through binoculars. His gunner, Corporal James Wilhelm, tracked the lead Panzer IV through the gun sight. The range was closing. 1,200 yards. 1,000. 800. Fire, Lupe commanded. The 3-inch gun roared. The Panzer IV lurched and began smoking. Wilhelm was already loading another round, the loader working frantically to keep up with the commander's fire commands. They fired 4 times in 90 seconds. 2 Panthers destroyed. 1 Panzer IV disabled. One miss that kicked up a geyser of dirt behind the German formation. At ranges where the M10's gun could penetrate German armour, the German tanks could not effectively return fire against hull-down positions. The Americans destroyed tank after tank. When German forces tried to flank the positions, American artillery hammered them. Forward observers called in fire missions with brutal precision. 105mm howitzers dropped shells directly onto German formations attempting to maneuver. When they tried to press forward directly, they ran into minefields that the Americans had laid during the night. The 8th, 99th lost 7 M10s during the battle. 3 to German anti-tank guns that finally located American positions. 2 to mechanical failures that left them stranded under fire. 2 to lucky hits from German panzers firing blind at American muzzle flashes. but the Germans lost 38 panzers destroyed or disabled. The kill ratio was better than 5-1 in favor of the Americans. Von Breusch withdrew in shock. His veteran crews, his superior armor, his tactical experience, none of it had mattered against American firepower properly employed. The Green Americans he had expected to rout had instead destroyed a significant portion of his division's combat power. German after-action reports struggled to explain what had happened. Some blamed inadequate reconnaissance. Others cited American artillery superiority and air support. Few acknowledged the more troubling truth. The Americans had deployed a new weapons system, optimized for a style of warfare Germany had not anticipated. The M10 battalions that fought at El Guetar operated according to doctrine McNair had developed. They chose their positions carefully, exploiting terrain to maximize their fields of fire while minimizing their exposure. They remained mobile, ready to displace if German forces located them. They coordinated closely with infantry and artillery, creating layered defenses that destroyed enemy attacks before they reached American lines. This was not the way German assault guns fought. Stooge battalions were attached to infantry divisions and moved with the assault troops, providing direct fire support against bunkers and fortifications. When employed as tank destroyers, Stooges used their low profile to wait in ambush, then engaged enemy armor at close range where their powerful guns were most effective. Both approaches had merit. Both reflected the tactical realities their respective armies faced. But they required fundamentally different vehicles. The M10's speed allowed it to race forward to threatened sectors, engage enemy armor, then withdraw before German forces could bring overwhelming firepower to bear. German assault guns, slower and less mobile, fought from prepared positions where their low silhouette and heavy armor provided better protection than mobility ever could. As the North African campaign progressed through the spring of 1943, more American tank destroyer battalions arrived. They equipped themselves with M10s, trained in the doctrines McNair had developed, and deployed to the front lines. The 601st Tank Destroyer Battalion distinguished itself at Maknassi in late March. The 805th fought at Hill 609 during the final push toward Tunis. The 776th provided crucial support during the assault on Bizerte. Each battalion learned from the experiences of those who had fought before them. Tactics evolved, positioning improved, coordination with supporting arms became more effective. By the time the Axis forces in Tunisia surrendered in May, American tank destroyer crews had developed confidence in their vehicles and their tactics. They had learned that speed and positioning mattered more than thick armor. They had learned that coordinated fires from multiple directions defeated even superior German tanks. They had learned to trust their commanders to position them where they could be most effective. The invasion of Sicily in July 1943 brought M10s to European soil for the first time. Tank destroyer battalions landed alongside infantry divisions, their M10s rolling off LSTs onto hostile beaches under intermittent artillery fire. Lieutenant William Reeder commanded a platoon of M10s from the 899th Battalion, the same unit that had fought at El Guetar. His vehicles came ashore at Gela on the morning of July 10th. The water was rough. The LST ramp dropped into surf that reached halfway up the M10's hull. Reeder's driver, a farm boy from Iowa named Tommy Hendricks, gunned the diesel engines and drove into the Mediterranean. Salt water sprayed through the open turret. The vehicle lurched as waves struck its side. For 30 terrible seconds, Reeder thought they would founder and sink. Then the tracks found solid sand, and they rumbled forward onto the beach. The fighting in Sicily tested American equipment and doctrine under conditions different from the North African desert. Mountainous terrain, narrow roads, villages built of stone where every building could hide anti-tank guns. The M10 adapted well. Its open turret, so vulnerable on paper, proved advantageous in close terrain. Crews could spot threats without relying on limited visibility periscopes. They could communicate with accompanying infantry directly, coordinating attacks without complex radio procedures. The vehicle's speed allowed it to move quickly between defensive positions as German and Italian forces counterattacked. During the fight for Troina in early August, Reeder's platoon supported infantry from the 1st Infantry Division. The town sat on a hilltop, surrounded by olive groves and stone walls. German paratroopers occupied buildings that commanded every approach. American infantry attacked for 3 days without making significant progress. On the 4th day, Reeder received orders to provide direct fire support. He positioned his M10's hull down behind stone walls, their 3-inch guns elevated to fire over the crest. The gunners aimed at specific buildings that German observers were using. Each round punched through stone walls 2 feet thick, collapsing entire structures. The Germans had never faced this kind of precision fire support. Their own assault guns were engaged elsewhere. Italian artillery could not match American fire control. After 2 hours of methodical destruction, the German paratroopers withdrew. American infantry entered Troina that afternoon. By September, when Allied forces landed at Salerno on the Italian mainland, the M10 had become the standard American tank destroyer. 63 separate tank destroyer battalions would eventually deploy to Europe, most of them equipped with M10s. These battalions represented an enormous investment in specialized anti-tank forces. Each battalion included 36 M10s, organized into 3 companies. Supporting elements included reconnaissance platoons, anti-aircraft platoons, and maintenance sections. The organizational structure reflected McNair's vision of independent units that could be attached to divisions as needed, providing anti-tank capability wherever enemy armor threatened. In practice, the reality differed significantly from McNair's theory. Tank destroyer battalions were almost never held in reserve to counter massed enemy armored breakthroughs. Instead, they were attached semi-permanently to infantry divisions, where they provided a combination of direct fire support, anti-tank overwatch, and mobile firepower that commanders found invaluable. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The M10s fired far more high-explosive rounds at bunkers, buildings, and infantry positions than armor-piercing rounds at enemy tanks. This was not a failure of doctrine. It was an adaptation to the realities of combat in Italy, where German forces rarely concentrated large armored formations, but instead used terrain and fortifications to delay the Allied advance. American commanders used M10s as mobile artillery, as assault guns, as direct fire support for attacking infantry. The vehicles proved remarkably versatile. Their 3-inch guns could destroy stone buildings that sheltered German defenders. Their speed allowed them to keep pace with advancing infantry. Their open turrets allowed crews to spot enemy positions that would have remained invisible to tankers sealed inside closed vehicles. The Battle for Monte Cassino in early 1944 demonstrated both the M10's capabilities and its limitations. The 751st Tank Destroyer Battalion supported the 36th Infantry Division during the disastrous first assault on the Abbey. Staff Sergeant Anthony Casamento commanded an M10, positioned to provide covering fire for infantry crossing the Rapido River. The position was exposed. German observers on the heights above could see every American movement. Casamento's vehicle drew fire from multiple German anti-tank guns. An 88mm round struck his M10's turret, penetrating the thin side armor and killing his gunner instantly. Shrapnel wounded Casamento and his loader, but the vehicle remained operational. The diesel engine still ran, the gun still fired. Casamento, bleeding from multiple wounds, took over the gunner's position himself and continued firing at German positions until his ammunition was exhausted. He then directed his driver to withdraw under smoke while he provided covering fire with the 50 caliber machine gun mounted on the turret ring. Casamento survived. His actions earned him the Silver Star, but his experiences illustrated the vulnerability that came with the M10's design philosophy. German forces facing M10s in Italy learned to respect them. Captured German tactical reports from late 1943 mentioned American Panzerjäger multiple times, noting their speed and the difficulty of engaging them effectively. One report from the 26th Panzer Division stated that American tank destroyers avoided direct engagements whenever possible, preferring to fire from concealed positions before withdrawing. The report noted that this made them extremely difficult to destroy with counter-battery fire. Another report from the 15th Panzer Grenadier Division warned that American tank destroyers often worked in pairs, with one vehicle drawing fire while the other maneuvered to a flanking position. The Germans were learning to respect American tactics, even when they maintained contempt for American equipment. German anti-tank guns could destroy M10s easily. 88mm flak guns, pressed into service as anti-tank weapons, could penetrate M10 armor at any range. The 75mm PaK-40 anti-tank gun, standard equipment in German infantry divisions, could penetrate the M10's frontal armor at combat ranges. But hitting a fast-moving target required skill, and mountain crews learned to exploit their mobility. They would appear suddenly, fire several rounds, then withdraw before German gunners could respond. This hit-and-run approach frustrated German commanders accustomed to more predictable engagement patterns. By the spring of 1944, as Allied forces prepared for the invasion of Normandy, tank destroyer doctrine had evolved significantly from McNair's original concept. The vision of independent battalions racing to meet enemy breakthroughs had given way to integrated combined arms teams, where tank destroyers worked closely with infantry and armor. The M10 had evolved from a specialized tank killer to a multi-purpose fire support vehicle. Its usefulness far exceeded its original design parameters. D-Day brought tank destroyer battalions to Normandy as part of the largest amphibious invasion in history. M10s landed on Utah and Omaha beaches, their crews struggling through the chaos of the initial assault before pushing inland to support the breakout from the beachhead. The 634th Tank Destroyer Battalion landed at Utah Beach on June 6th. The 899th landed at Omaha. The 803 came ashore at Utah on June 7th. Each battalion brought 36 M10s and hundreds of men trained in the doctrine McNair had developed. The hedgerow country of Normandy presented new challenges. Fields, separated by earth banks, topped with thick vegetation, created a maze of tiny compartments where visibility rarely exceeded 100 meters. German defenders positioned anti-tank guns in hedgerows, waiting until Allied vehicles came within point-blank range before opening fire. American tank and tank destroyer crews suffered heavy casualties, learning to fight in this terrain. But they learned quickly. The M10's open turret again proved advantageous. Commanders could see over hedgerows more easily than tankers inside closed Shermans. They spotted German positions and called in artillery or maneuvered to flanking positions. The vehicle's speed allowed it to advance rapidly when gaps appeared in German defences, exploiting breakthroughs before enemy forces could reorganize. Corporal Eugene Luciano, a gunner with the 803 Battalion, later described fighting in the hedgerows as the most stressful combat he experienced during the entire war. Every field might contain a hidden Panther or an 88. Every hedgerow might hide German infantry with Panzerfausts. The crews lived in constant tension, knowing that their open turrets made them vulnerable to grenades and small arms fire at close range. And the 3-inch gun, while inadequate against Panther frontal armor, remained effective against Panzer IVs and lighter German armor that still constituted the majority of enemy armored forces. When the Americans finally broke out of Normandy in late July during Operation Cobra, tank destroyer battalions raced forward with the advancing armored divisions. They moved so fast that German units often found themselves cut off before they realized American forces had passed through their positions. M10s appeared at crossroads, blocking German retreat routes. They engaged enemy columns, attempting to escape encirclement. They provided overwatch for advancing infantry and armor, their crews alert for any sign of German counterattacks. The pursuit across France in August and September 1944 showcased the M10 at its most effective. Speed mattered more than armor in this fluid, mobile warfare. The Americans were advancing so rapidly that German forces rarely had time to establish prepared defenses. M10s raced from one objective to the next, their crews living in their vehicles, sleeping in shifts, fighting running battles against German rear guards. The 776th Tank Destroyer Battalion covered over 400 miles in 3 weeks, destroying dozens of German vehicles, and supporting the liberation of countless French villages. One M10, named Sirocco, serving with the French 2nd Armoured Division, destroyed a German Panther tank in the Place de la Concorde during the liberation of Paris in August 1944. The engagement became famous. A French-crewed American tank destroyer eliminating a German heavy tank in the heart of Paris while crowds of civilians watched. The symbolism was perfect. Lieutenant Philippe Leclerc de Hautecloque commanded the French crew. They had spotted the Panther near the Tuileries Garden, its commander apparently confused by the chaos of the liberation. Leclerc maneuvered Sirocco through streets packed with celebrating Parisians, his crew shouting at civilians to clear the way. They approached to within 300 meters before the Panther crew recognized the threat. The German commander traversed his turret toward the M10. Leclerc's gunner fired first. The armor-piercing round struck the Panther's turret ring, precisely where the rotating turret met the hull. The massive German tank shuddered and stopped moving. Smoke poured from the hatches. The crew bailed out and surrendered. Parisians mobbed Sirocco, climbing onto the hull and turret, kissing the crew, offering wine and cigarettes. Leclerc stood in the commander's position, grinning and waving, knowing this moment would define his war. By autumn 1944, as Allied forces approached the German border, the M10's limitations had become increasingly apparent. The newest German tanks, Panthers and Tigers, were essentially immune to the 3-inch gun, except at close ranges and from favorable angles. American tank destroyer crews had to outmaneuver their opponents, using speed and positioning to compensate for inadequate firepower. The Army attempted to address this with improved ammunition. Tungsten core HVAP rounds could penetrate heavier armor, but these special projectiles remained in short supply throughout the war. Crews received perhaps a dozen HVAP rounds per vehicle, with instructions to use them only against heavy German armor at close range. American tank destroyer crews learned to coordinate attacks with Shermans and artillery. When facing Panthers, they would maneuver to flanking positions while other units engaged frontally. They would call in artillery to suppress German tanks while advancing to ranges where even their 3-inch guns remained effective. They improvised constantly, adapting tactics to overcome material disadvantages. This was the American way of war. Not overwhelming individual superiority, but overwhelming collective power. Not invincible weapons, but effective systems that coordinated multiple capabilities. Not perfect vehicles, but adequate vehicles employed by crews who understood how to maximize their strengths and minimize their weaknesses. The 634th Tank Destroyer Battalion developed a tactic they called the Wolf Pack. 3 or 4 M10s would coordinate to engage a single German heavy tank. One vehicle would fire at the Panther's frontal armor, drawing its attention. The rounds would not penetrate, but they would force the German commander to focus on that threat. While the Panther engaged the first M10, the others would maneuver to flanking positions at high speed, using their 30-mile-per-hour top speed to reach positions before the Panther could respond. Once in position, they would fire at the thinner side or rear armor. The tactic worked remarkably well. German Panthers and Tigers were formidable when they could engage enemies frontally, but they were vulnerable when surrounded. By the Battle of the Bulge in December 1944, when Germany launched its last great offensive in the West, M10 battalions had become indispensable elements of American defensive and offensive operations. They fought desperate rearguard actions as German panzer divisions drove deep into American lines. They held crossroads against overwhelming odds. They sacrificed themselves to buy time for other units to escape or regroup. The 634th Battalion found itself nearly surrounded at Street Vith during the opening days of the offensive. German armor attacked from multiple directions. American infantry was streaming to the rear. The situation was chaos. Lieutenant Colonel William Westmoreland commanded the battalion. He positioned his M10s at critical road junctions, ordering his crews to hold at all costs. For 3 days, the 634 fought off repeated German attacks. They destroyed 16 Panthers and Tiger tanks during those 72 hours. They lost 23 of their own M10s. When Westmoreland finally received orders to withdraw on December 20th, only 9 operational vehicles remained. The battalion had been destroyed as a fighting force, but it had bought time for the 7th Armoured Division to organise a defence that would hold Streetvith for another crucial day. The most famous American soldier of the war, Lieutenant Audie Murphy, earned his Medal of Honor during the Battle of the Colmar Pocket in January 1945 by climbing onto a burning M10 and using its 50 caliber machine gun to repel attacking German infantry. Murphy's company from the 15th Infantry Regiment was being overrun by 6 German tanks and approximately 250 infantry. Murphy ordered his men to withdraw while he remained to direct artillery fire. When a German round set an M10 from the attached tank destroyer platoon on fire, Murphy climbed onto the burning vehicle and took control of its 50 caliber machine gun. He stood there for nearly an hour, wounded and exposed, calling in artillery coordinates by radio while firing at German soldiers advancing through the snow. The M10 belonged to the 827th Tank Destroyer Battalion. Its crew had abandoned the vehicle moments before Murphy climbed aboard, fearing that flames would reach the ammunition stored inside. Murphy ignored the danger. He fired the 50 caliber machine gun until it ran out of ammunition, then used his carbine. German fire wounded him in the leg, but he remained on the burning vehicle, adjusting artillery fire that eventually broke up the German attack. When Murphy finally withdrew, smoke and flames were pouring from the M10's engine compartment. The vehicle was completely destroyed by fire within minutes of Murphy leaving it. The engagement became legendary. Not because of the M10 itself, but because of what Murphy did with it. That distinction mattered. The M10 was never going to win wars by itself. No weapon system could. Wars are won by soldiers who use the weapons they have to accomplish missions under impossible conditions. The M10 gave American soldiers a tool that was fast enough, reliable enough, and powerful enough to matter. That was sufficient. By the time Germany surrendered in May 1945, American tank destroyer battalions had destroyed thousands of German armoured vehicles. The 899th Battalion alone was credited with destroying over 100 enemy tanks and assault guns. The 634th destroyed 93. The 776th destroyed 87. Exact numbers remain disputed. Different units kept different records. Many destroyed vehicles were never officially confirmed. But the cumulative impact was undeniable. M10 battalions had fought from Tunisia to Sicily to Italy to France to Germany itself. They had adapted their tactics to every kind of terrain and every kind of enemy. They had evolved from specialized anti-tank hunters to versatile fire support platforms that could accomplish any mission commanders assigned them. After the war ended, military historians analyzed what tank destroyer battalions had accomplished. The verdict was mixed. McNair's original doctrine, the vision of independent battalions held in reserve to counter massed enemy armour, had never materialized. The anticipated mass panzer attacks never occurred on the Western Front. German armour was too dispersed, too scarce, too carefully husbanded to risk in concentrated assaults against prepared American defences. Instead, tank destroyers had fought as integrated elements of combined arms teams. They had destroyed more bunkers than tanks. They had fired more high-explosive shells than armour-piercing rounds. By doctrinal standards, the tank destroyer force had failed. By practical standards, it had succeeded brilliantly. The M10s had done what was needed when it was needed. That was the only standard that mattered. The M10 remained in American service through the end of the war, but never in the numbers originally planned. Production ended in December 1943, after 6,547 vehicles had been built. Ford and Fisher both stopped M10 production to focus on other weapons, including the M36 tank destroyer with a 90mm gun and the faster M18 Hellcat. These newer vehicles addressed the M10's limitations while maintaining the mobility that American doctrine prized. But the M10 soldiered on, reliable, available, adequate. The vehicle that Hauptmann Becker had evaluated at Kummersdorf in April 1943 embodied choices that defined American armoured warfare. Speed over protection, reliability over sophistication, mass production over individual excellence. These were not the choices German engineers would have made. German doctrine prized technical superiority and crew quality. The finest tanks crewed by the finest soldiers, defeating numerically superior enemies through skill and better equipment. It was a philosophy born of necessity. Germany lacked America's industrial capacity and manpower reserves. German forces had to achieve favorable exchange ratios, had to win battles with fewer losses than their enemies, because every casualty and every destroyed vehicle represented an irreplaceable loss. America faced different constraints. Industrial capacity was effectively unlimited. Manpower was abundant. The challenge was not building enough weapons, but deploying them effectively before the war ended. American doctrine accepted losses because losses could be replaced. What mattered was accomplishing objectives, destroying German fighting power, liberating occupied territory, ending the war as quickly as possible. The M10 served those objectives well, not through technical superiority but through adequate capability, delivered in overwhelming quantity. By war's end, American factories had produced nearly 300,000 military aircraft, 86,000 tanks, and hundreds of thousands of other armored vehicles. The scale dwarfed anything Germany could match. When German engineers at Kummersdorf evaluated captured American equipment, they were not just studying individual weapons. They were encountering a completely different philosophy of warfare. The British and Soviets shared some of America's industrial advantages, but both nations designed weapons differently. British tanks emphasized protection, reflecting an army that valued crew survival and could not easily replace casualties. Soviet tanks emphasized simplicity and mass production, reflecting an army with enormous manpower but limited technical expertise. America alone had both vast industrial capacity and highly educated workforce. American weapons reflected this unique combination. Complex enough to be effective, simple enough to mass produce, sophisticated enough to give crews advantages, reliable enough that crews with modest training could operate them. The M10 tank destroyer represented this balance perfectly. Its chassis was based on proven Sherman components that thousands of factories could manufacture. Its 3-inch gun was powerful enough to matter, but not so complex that production bottlenecks would limit availability. Its open turret reduced manufacturing costs and weight while providing genuine tactical advantages. The vehicle was not optimal by any single measure, but it was optimal for America's strategic situation. Some military historians later criticized the tank destroyer concept as wasteful. They argued that resources devoted to specialized anti-tank vehicles should have been used to build better tanks. They noted that tank destroyer battalions accomplished most of their missions by destroying things other than enemy tanks. They questioned whether the elaborate organization and doctrine justified the resources committed. These criticisms missed the point. The tank destroyer force existed because America could afford it. Industrial capacity was not a limiting factor. Manufacturing M10s did not prevent manufacturing Shermans or P-51 fighters or Liberty ships. America built everything simultaneously because America could. The question was never whether to build tank destroyers or tanks. The question was how best to employ the massive military force American industry created. Tank destroyer battalions provided that employment. They gave commanders mobile, powerful fire support that could be deployed wherever needed. When that support destroyed German tanks, excellent. When it destroyed bunkers or supported infantry or provided anti-aircraft defense, equally valuable. The versatility justified the investment. By the time the last M10 was retired from American service in the 1950s, the vehicle had served far longer than anyone expected. Some went to Allied nations under military assistance programs. Britain received several dozen for training purposes. Yugoslavia incorporated captured German M10s into its post-war army. The Greek army used M10s during its civil war in the late 1940s. Some went to scrapyards, their steel recycled for peacetime purposes. A few went to museums where they remain today, silent witnesses to a particular moment in military history when America built weapons optimized for mass warfare. The M10 never achieved the fame of the Sherman tank or the romantic mystique of German Tigers and Panthers. It was not photographed as frequently. War correspondents rarely wrote about it. Veterans who served in M10 battalions came home to a nation more interested in forgetting the war than analysing its equipment. But for the thousands of crews who drove M10s from Tunisia to Germany, the vehicle was more than adequate. It was what they had, and what they had was enough. Staff Sergeant Robert Lupi, the Detroit machinist who had commanded an M10 at El Guetar, came home to Michigan in October 1945. He returned to his factory job, married his sweetheart, raised 3 children, and never spoke much about the war. When his grandson asked him decades later what he had done during World War II, Lupe simply said he had driven a tank destroyer. He did not mention the Panthers he had destroyed, or the Silver Star he had earned, or the nightmares that woke him screaming for years after the war. He just said he had done his job. Hauptmann Becker's report from April 1943 ended up in German archives, one document among thousands evaluating enemy equipment. His observation that American tank destroyers represented a different design philosophy influenced few decisions. Germany continued building technically sophisticated vehicles until the very end. Panthers, Tigers, King Tigers, Jagd Panthers, each generation more powerful than the last. Each generation also more expensive, more complex, more difficult to produce and maintain. By the time Germany surrendered, thousands of incomplete vehicles sat in factories, lacking engines or transmissions or other components that Allied bombing had made unavailable. The Wehrmacht, that had conquered most of Europe with Panzer IIIs and Panzer IVs, ended the war with super-heavy tanks it could not fuel, could not repair, and could not produce in meaningful numbers. The Americans ended the war with parking lots full of M10s, M36s, and M18s, thousands of tank destroyers that had accomplished their missions and were no longer needed. The vehicles were sold for scrap metal or given to allies. America moved on to other concerns, other enemies, other wars. The contrast between German and American approaches to armoured vehicle design reflected deeper differences in how the two nations understood warfare itself. Germany believed wars were won through superior individual combat power, better tanks, better crews, better tactics. Concentrated force applied at decisive points by elite formations. It was a philosophy suited to a nation with limited resources and a tradition of military excellence. America believed wars were won through overwhelming collective power, adequate weapons produced in crushing quantities, adequate soldiers trained in effective doctrine, systems that coordinated multiple capabilities to achieve effects no single weapon could accomplish alone. It was a philosophy suited to a nation with vast resources and a tradition of industrial problem-solving. Neither philosophy was inherently superior. Both had won victories. Both had suffered defeats. But in the context of the Second World War, where industrial capacity and strategic resources determined outcomes as much as battlefield skill, American philosophy prevailed. The M10 tank destroyer was not the reason America won the war. No single weapon was. But it was emblematic of why America won. Because America built what it needed in the quantities required and employed those weapons according to doctrine that maximized their effectiveness. Because America accepted that individual superiority mattered less than collective power. Because America understood that adequate performance delivered in overwhelming quantity defeats excellent performance delivered in limited quantity. The lessons remain relevant. Military forces still struggle with the same fundamental choices: quality versus quantity, technical sophistication versus reliability, specialized excellence versus versatile adequacy. The M10 reminds us that these choices depend on strategic context, industrial capacity, and tactical requirements. What worked for America in 1944 might not work for other nations in other circumstances, but the principle endures. Match your weapons to your doctrine. Match your doctrine to your resources. Match your resources to your strategic objectives. Do that consistently, and you build military forces that win wars. The M10 did not achieve the 30 miles per hour that shocked Hauptmann Becker because American engineers discovered secret technologies. It achieved that speed because American doctrine demanded it and American industry delivered it. Speed was the design priority because American tank destroyer doctrine emphasized rapid response to enemy breakthroughs. Everything else, protection, firepower, crew comfort, was subordinated to that requirement. The result was a vehicle that could outrun anything else on tracks. A vehicle that gave American commanders options their enemies lacked. A vehicle that proved adequate to every mission assigned, despite limitations that would have been fatal in different circumstances. That adequacy, that flexibility, that reliability, those were the real achievements. Not technical superiority, not innovative engineering, just solid design executed brilliantly at industrial scale. The American way of war. The captured M10 that German engineers studied at Kummersdorf told them everything they needed to know about how America would fight the rest of the war. They saw a vehicle designed for speed and mass production. They documented its capabilities in meticulous reports. They understood the implications. But understanding did not help them. By April 1943, when Becker submitted his evaluation, Germany had already lost the war. The outcome was not yet certain. The fighting would continue for 2 more terrible years. But the balance of industrial power had shifted so completely in the Allies' favour that German victory had become impossible. The M10 was evidence of that imbalance. American factories had designed it, tested it, and begun mass production in less than a year. German factories, struggling with raw material shortages and Allied bombing, took years to develop new vehicles and could never produce them in adequate numbers. The war would be decided not by technical excellence but by industrial capacity. The Americans had both, the Germans had only the former. It was not enough. When Soviet forces captured Kummersdorf in April 1945, they found the motor pool full of captured Allied vehicles, British Churchills, French Char B-1s, Soviet 34s, American Shermans and M10s, all of them bearing German tactical markings, all of them sitting abandoned as their captors fled or surrendered. The vehicles were shipped east to Soviet testing facilities, where different engineers would evaluate them for different purposes. The cycle continued, weapons examined, lessons recorded, reports filed. Some of those vehicles survive today in museums, carefully restored, historically significant. Reminders of an era when industrial nations measured their strength in thousands of tanks and tens of thousands of aircraft. The M10 in museums today look smaller than photographs suggest, less intimidating. The open turret seems impossibly vulnerable. The armour looks thin. The gun appears modest. It is easy to wonder how such vehicles could have mattered. But they did matter, not because they were invincible, because they were adequate and available and employed effectively by crews who understood their limitations. Wars are not won by perfect weapons. Wars are won by imperfect weapons used by imperfect soldiers accomplishing imperfect missions under impossible conditions. The M10 gave American soldiers a tool for that work. It was fast enough to get them where they needed to be, reliable enough to keep working when everything else broke down, simple enough that ordinary men could operate it after reasonable training, and powerful enough to matter when the shooting started. That was all it needed to be. That was enough. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.